All right, everyone. Today we have a pretty quick lesson about multiplying polynomials. So we've worked on adding and subtracting polynomials here the first couple days of our lessons as our introduction here to Unit 10. So we talked in class on Friday about adding and subtracting polynomials. And we know that if we have a grouping in parentheses that's not being subtracted, we can go ahead and drop those parentheses, distributing the negative into the quantity being subtracted, and then we can combine our like terms. Remember, in order to combine like terms, we need to have the same variable with the same exponent. Then we simply add or subtract the coefficients, keep the terms in order from the largest exponent down to the smallest, and we call that standard form. Now today we're going to be introducing the concept of multiplying polynomials. And we remember from last unit that if you multiplied two terms together and the exponential bases were the same, we multiply the coefficients. 3 times 3 is 9. X to the squared times x to the power of 3 is x to the power of 5. So when we multiply variables, if the exponents match, we are always going to be adding those exponents together. We've talked about the distributive property back at the beginning of the year, and we've been using it through solving equations, that if we have a factor out in front of a quantity or a grouping of two terms, we need to distribute or multiply both terms by that factor. So 4 times 3x would give us 12x, and 4 times 12 would give us 48. But now what we're really going to focus on is what happens when that factor out in front of our grouping is a term that contains both a coefficient and a variable. So let's look at 2x squared minus 8. Inside of the parentheses, we're multiplying that by 3x. So we distribute a 3x to both terms. So that means we're doing 3x times 2x squared. And then we are subtracting 3x times that 8. 3 times 2 is 6, and x times x squared is going to be x to the power of 3. Remember, if the variables have the same base, meaning the variables match, we add their exponents. So that gives us 6x to the power of 3. Negative 3 times 8 is negative 24. And that x would just remain by itself. So as we work through some of these examples here and we are distributing, all we need to worry about is, does the factor we're distributing have the same base for a variable? And then do we add or subtract those exponents together? Well, we are multiplying. So in this case, we will always be adding our exponents. Now we're going to go ahead and take 2x cubed. And we're going to multiply that to this, let's make this a trinomial, 3x cubed minus 4x squared plus 3. We are distributing. So I'm going to multiply each term inside of our parentheses by 2x cubed. If we are multiplying, we multiply the coefficients, we add the exponents of our common bases. So 2 times 3 is 6. X to the third times x to the third. 3 plus 3 is 6. Multiply to the next grouping. 2 times negative 4 is negative 8. X to the third times x squared. 3 plus 2 is x to the fifth. Multiply that. 2x to the third times 3. And we are left with 6x to the power of 3. So we've gone ahead, we've distributed, we were left with these three terms. We can't combine like terms any farther because we have 6x to the 6, then x to the power of 5, x to the power of 3. The exponents don't match. The last example I will leave you with here today, we're going to distribute 3x, which is a monomial, to 2x minus 8, and then we are going to subtract 3x to the third times 2x squared plus 1. So if you are multiplying by various factors, meaning multiple ones, we can't just drop the parentheses until we actually distribute. So we'll distribute the 3x just to the 2x minus 8 because you can only distribute it to the quantity that it directly sits in front of. We're subtracting 3x cubed times 2x squared plus 1. So the negative 3x only distributes to the last two terms in parentheses. You don't distribute the 3x all the way to those terms. You're subtracting in between here for this operation. So you only distribute it to the quantity that it is directly in front of. So 3x times 2x, 6x squared, 3x times 8, negative 24x. We're distributing negative 3x to the third because you're really subtracting the product here. So we're going to be distributing the negative as well as 3x cubed. Negative 3 times 2 is negative 6. We add the exponents, negative 6 to the power of 5. Negative 3x cubed times 1 gives us minus 3x cubed. Remember, we want to rewrite our solutions in standard form, meaning the largest exponent down to the first one. So we'll start with negative 6x to the fifth minus 3x cubed plus 6x squared minus 24x. We don't have a constant, but that would always go at the end. And I've rearranged my exponents from 5 to 3 to 2 to 1. From largest down to the smallest. So as you guys work on distributing, remember our exponent rules stay the same. If we multiply the same base, we add the exponents. We multiply coefficients, and again, we can only combine like terms if we have the same variable matched with the same exponent through addition and subtraction. We will cover some more examples in class and have some time to work. Have a great weekend.